Hello everyone. So let's discuss the given problem. What we need to find if the length of the projection, the line segment joining these particular points, 5, 1, minus 1, 4 and 4, minus 1, 3. Okay, for the on the plane x plus y plus 7 equal to 7. X plus y plus z equal to 7. Right? Uh, so the options are given as this. Now to find this, the first step would be to find the directional vector of AB, right? So to find that, we'll simply subtract the corresponding coordinates from each other, and the answer would be, that is 5 minus 4. Sorry, we take, if we have to find AB vector, we divide B vector minus A vector, right? So B minus A, that would be 4 minus 5 minus I cap. Okay, then minus 1 minus 1 minus 1 minus minus 1, right? It would be 0 plus 0, that is J cap. Now the third coordinate is 3 minus 4, that is plus k cap. Okay, this is the AB vector. I'll just write it again. Okay, so its value would be, the length of AB would be equal to the determinant of this. Okay, that would be equal to root 2. Now given the equation of x plus y plus z equal to 7, that is the equation of plane, from this we can identify the normal, the vector normal, right? That would be equal to I cap plus j cap plus k cap. Okay, correct. So, and the value of this would be equal to root 3. Now we come to solving part. We have all the necessary calculations we need to do right now. So now we understand solution. The direction ratios of AB are, as I said, 101, right? Now the theta between the line AB and the normal of the plane is, can you guess? It is given the normal of the plane is theta, right? Now it is theta between the normal of the line and the line segment, but we need to find the angle between the projection with the plane. So we need the angle between the line and the plane, that would be equal to 90 minus theta. So first we'll find the value of cos theta. So cos theta is, the formula of cos theta is a1 AB vector dot n vector upon AB determinant plus n determinant, right? That would be equal to 1 into 1, 0 into 1, 1 into 1, root 2 upon root 3, right? So to giving the value root 2 upon root 3. Now, so as I said, we need to find the projection on plane. So we need to find cos of 90 minus theta. That would be equal to sine theta, right? Now, so projection of line is AB determinant into sine theta. AB is equal to root 2. We know cos square theta plus sine square theta is equal to 1. So if we put in the values, it would give sine theta equal to 1 minus under root of 1 minus 2 by 3, right? So this would be root 2 into under root 1 by 3. Cross multiplying those two values would give us under root 2 by 3. The answer is B.